Algebra 2, and welcome to the Chapter 5.3 installment of our series. So today we're going to be talking about solving quadratic equations by finding square roots. So we're going to start with a review of square roots and their properties. So first of all, we have the square root sign, which actually is called a radical sign, not just a square root sign. And we'll talk more about that later, but it is a radical sign. And we're going to have a number underneath, and that number is called the radicand. Okay. And we want to know, what does the square root of 9 equal? And you're probably saying, well, the square root of 9 equals 3, right? And the reason it equals 3 is because 3 times 3 is 9. And this is where the square root part comes in, because the square root wants you to do a number times itself. So a product of two numbers, okay, equals the radicand. But can you think of any other numbers that the square root of 9 also equals? Also equals -3, because -3 times -3 is also a positive 9. And we can combine these and actually write it as plus or minus 3. So the positive 3 is called your principal root, and that's the one that you would typically give. Like if somebody just is like, hey, what's the square root of 25? You're like, hey, it's 5. But there's also another one, and we just don't usually say that one. But now that we're solving quadratics and we need two answers, you got to have them both, okay? So the two properties that we're going to use today, we're going to be multiplying and dividing. So we have the product property for radicals. And it is the square root of a product equals the product of the individual square roots. This is going to help you simplify numbers. So for instance, if you have the square root of 24, I can rewrite this as the square root of 4 times 6, which is the square root of 4 times the square root of 6, which is going to be 2 square root of 6. This is how you simplify radicals. Okay. When you split it apart into your product, one of the numbers needs to be a perfect square root. So 4, 9, 16, 25, 36, a number you can actually take the square root of. Our other property is the quotient property for radicals. Okay. And it is if you have a radical of a quotient, that you can split it apart and have the quotient of two radicals. So for instance, this makes square rooting fractions really easy. If you have the square root of 4/9, which 4/9 itself can't be reduced. So this is the square root of 4 over the square root of 9, which is going to be 2/3. Alright, so we'll use these properties. So let's go on. So just quickly, a couple of examples with those operations. We're just going to concentrate on the multiplying and dividing. So for instance, if we have the square root of 500, and that's all that is, we want to simplify this. So we're going to split it up into a product, and one of the numbers needs to be a perfect square root. So looking at this, I'm thinking 100 times 5. Because that would be the square root of 100 times the square root of 5, and the square root of 100 is 10, so 10 square root of 5, and that would be your answer. So what happens if we actually have multiplication to start with? Like 3 square root of 12 times the square root of 6. Well, our product property says we can multiply these together. You can also simplify before you multiply. So I'm actually going to do that because I have a calculator sitting here and I don't want to get into a large number. So I'm going to simplify just the square root of 12. So the square root of 12 is going to be the square root of 4 times 3, which is going to be the square root of 4 times the square root of 3, and so we get 2 square root of 3. But I have this 3 out front, so it's 3 times, so this is going to be 6 square root of 3 times the square root of 6. Now I'm going to multiply those together and get 6 square root of 18. But then, can we simplify the square root of 18? So it's the same thing with fractions, like a fraction always has to be reduced, square root always has to be reduced. So let's see here, so the square root of 18 can go into 9 and 2. And so another thing, instead of doing this step and stopping at the product, sometimes you can go straight here if you want to. So this can be the square root of 9 times the square root of 2, because that makes 18, which is 3 square root of 2, but I got to bring up this times 6, so 6 times is going to be 18 square root of 2, and that would be our answer. Okay, we're going to fit one more in here over to the side, and that's going to be the square root of 25/3. And does that simplify? No. So we're going to make that into the square root of 25 over the square root of 3. And what's the square root of 25? So this is going to become 5 over the square root of 3. And now I need to pause and tell you, you may never have a square root in the denominator of a final answer. So let me repeat that. You may never have a square root in the denominator of a final answer. So what do? We do what's called rationalizing the denominator. And I'm going to multiply this by the square root of 3 over the square root of 3. Because what is the square root of 3 over the square root of 3 equal? That just equals 1. So I'm multiplying this by 1, right? You can do that. That's a legitimate operation. I'm not changing anything. So then on top, I'm going to have 5 square root of 3, and on the bottom, the square root of 3 times the square root of 3 is 3. And you might check that you know that that is 3. So now I no longer have a square root on the bottom. So a little more about rationalizing the denominator real quick. What if I have the square root of 2/11? So this happens when you're dividing. So here I'm dividing, and so my quotient property says I can split that up. Okay, great. And neither of these actually simplify at all, so I'm stuck there. But you can't have that square root on the bottom. So you multiply by 1, but instead of writing it as a 1, we write it as a square root of 11 over square root of 11. And now I get the square root of 22, because my product property says I multiply those together, over 11. So what happens though if we have like 3 over 1 minus the square root of 2? Like just to show you, hey, this has a square root on the bottom. But the difference is that this also has a binomial on the bottom, where these just had a single term or monomial on the bottom. In this case, you would multiply by the conjugate. So still 1, but this is called the conjugate. That's how you spell it. All right. And the conjugate is just replacing the middle term. So if we have a plus b, the conjugate is a minus b, or vice versa. So those are conjugates of each other. So then on top, we're going to distribute, and we're going to get 3 plus 3 square root of 2. And on the bottom, we're going to FOIL. So here's first, 1 times 1 is 1. But then if we look here, outside is going to be a positive square root of 2, and inside is going to be a negative square root of 2, and they're going to cancel. And then last is going to be a negative 2, because the square root of 2 times square root of 2 is 2, and I have that negative sign in there. So those cancel, and we get 3 plus 3 square root of 2 over negative 1, and we'll just leave it like that. Well, no, we won't. We're going to divide by negative 1. Negative 3 minus 3 square root of 2. There you go. There's multiplying by the conjugate. It's a part of rationalizing the denominator. Okay, so we're finally ready to solve an equation using a square root. So keeping in mind these are going to have two solutions because of the whole plus or minus thing we talked about at the very beginning. So an easy example would be like x squared equals 16. Okay, you're going to square root both sides because a square root is how you get rid of a squared. This is going to be x equals plus or minus 4. And if you happen to have a number that doesn't have a nice square root, like we'll do 18, square root both sides, x equals, we got to split up 18 into the square root of 9 and the square root of 2, so it's going to be plus or minus 3 square root of 2. Make sure you're following along and you know where I'm getting these numbers from. Alright, lastly I got these two equations for us to solve. So what you want to do is you want to try to get x squared by itself if possible. So this first one we're going to start by adding 6, which is going to be 4x squared equals 48. Then we're going to divide by 4 and gives you x squared equals 12. So now that x squared is by itself, square root both sides. Do not square root both sides up here. That would be a huge mess. You can't do anything with it. Wait till you get here to square root both sides. X equals plus or minus, because we got our two solutions, and 12 separates into the square root of 4 times the square root of 3. So that is 2 square root of 3. And our other one here, 1/5 times the quantity x minus 4 all squared equals 6. First thing we're going to do is we're going to multiply the whole equation by 5. That's going to cancel our 5th on this side and gives us a 30. Do not do anything else with that squared. From here, square root both sides. So the square root and the square cancel. You get x minus 4 equals plus or minus. Can we break down the square root of 30? 4 doesn't go into it, 9 doesn't go into it, 16 doesn't. We made it halfway, so we're good there. We're going to leave it, the square root of 30. And then you're going to add 4. And preferably you're going to write 4 in the front. So 4 plus or minus the square root of 30. Okay, I know this is a lot of information. Sorry about that. But please make sure you understood everything. If you have questions, let me know, and we will further discuss this in class. Have a good day.